Hello, friends. My name is Sahil Sani, and welcome to another episode on my channel where I will be taking you through statistical process control. Now, have you ever wondered how Manchester United played over the weekend? Well, I was really hurt by it, and I was trying to analyze the data of how exactly this happened. I was thinking through it, and I decided that this week I'm going to do things a little bit more different. I'm going to take you through statistical process control, and I'm going to take you through the charts, but we are going to see how Manchester United managed to draw because of a lack of quality control on their end. So I'm going to explain it to you in such terms that we all understand it and how this can apply even in your favorite football shows. Let's move on to the next slide. So already we've talked about these five core tools, and I will be making a video on all of these. If you do have any comments or if you do have any questions, please leave it in the comment section below so that I can answer all your questions and know exactly what you want to know about the statistical process control. So let's get right into it. So as we know, statistical process control is fed by data which is retrieved from operating processes. So, in terms of training, now you can see that Manchester United uses different training methods for all their players. They have, the striking positions, they have the defenders, they have the midfielders. Now, obviously, there's different ways to collect all this data from the particular players in terms of fitness of the players. Now, how is fitness of the players measured, you can ask? And that is through variable data. They can track your heartbeat, they can track your weight, daily weight, and attribute data would mean that, let's say you get an injury, and how often are you getting injured, and what is the process? Is there a process difference in training, or what exactly is it? So as we know that variable data is way more accurate than attribute data due to the it being measured and not just simply counted. So you can find that if you're weighing a player and you weigh their weight, if you want to see how fit they are and you want to see how many calories they're taking in, then obviously you can see it through going to the gym, weighing them on the weighing scale, getting their weight all the time. So that is all variable data. But then attribute data is also very important where there's a case of multiple defects affecting a product or a process. Now, if you watch the game over the weekend, you know that Manchester United, and by the way, I am a great fan of Manchester United. I think, I'm one of like their biggest fans, and I was really disappointed when, I saw Cristiano Ronaldo coming in the second half, 60 minutes down the line, and I actually felt so bad that we were 1-0 up, and then, they just came and equalized. But it is a case of choosing the right players, going through the same process. Now, Solskjaer said that, they needed to rest because they had played a good game against Villarreal over the Champions League. But again, how do you distinguish that? So it's a lot of thinking to do. So what we can see here is that this is a whole chart which I had even given you last week, and I'm going to take you through four charts for today's video. I'm going to take you through the X bar R chart, the C chart, the U chart, and the NP chart. So let's get right into it. So as you can see here, the first chart we're going to go through is the X bar stroke R chart. And this is mainly to do with variable data. Now let's take it through a process simply. Your weighing scale, you're a player, you have a good weight difference, you're counting your calories every week, like you see that per week you're losing some kilos, so you're constantly weighing it on a weighing scale, and you maybe out of the week you take 5 days in a week, a sample of how much your weight is and how much weight you've lost on the previous week. You can't lose so many kilos or so many grams in a day. So that is what the X bar chart represents. So in this diagram, you can see that it's all the mean of all means. So if you see this particular graph here, this is the mean, and this line here is the mean of all the means. So that's the center line. This is the upper control limit, and this is the lower control limit. Okay, so in this kind of chart, you can find that you have a lot of means. So as you're weighing yourself and you're weighing your scale on your particular weighing scale, and you see that fine, per week you're losing 100 grams a day, for instance, and then you take that as an average. So that will be put on this blue graph right here. Now, how much you're losing over the particular period, so the average of all averages is this center line here. Let's say you get a certain spike, okay, or a lower spike. This means that you've lost a lot of weight on a particular week, and this means that you could have even gained it if you go into a negative. So this is how a control chart is actually working. Then you have the R chart. Now the R chart is a different kind of chart, which is similar to the X chart. It's, if you put it together, you can see that this will be the range. So the range, you can find that maybe one day you're losing 100 grams. The next day you've lost only 20 grams. So the range is 80 grams. Okay. So per data set, you're actually putting this information. Now let's get into the next chart. So let's go right into the C chart, which is also for attribute data. So the C chart, now the data points are taken per lot produced. So for example, the number of defects per lot of 100 pieces produced. This data is then put into a C chart, and hence it is used to analyze the data. Okay, the shifts could be caused by fatigue, disinterest, an error in the process, and these are just a few examples. Now, if we look at the game over the weekend, the Manchester United game, I can see that there's a lot of issues with the processes, and there's a lot of issues in the defects. And okay, let's not even take that game. Let's take the Villarreal game, and when Diego Dalot was on the right back and De Gea was keeping. So Diego Dalot, he was surpassed almost for so many times. They were just taking advantage over that right back because our main guy, Aaron Wan-Bissaka, was in there. So I can see that in the training ground, there's a lot of errors into this process whereby they're not focusing on these through balls maybe. So that could be a defect. Per 100 passes produced, you have so many defects, and that is what a C chart is used for. And we could see that in the issue that maybe be going back in line, you could see that that is coming from the training. So I mean, obviously, it could be something else, but you let me know in the comments down below of why that could have been happening. But I know for a fact that it could have been in the training ground that he wasn't very well prepared. So you let me know down in the comments and give me a thumbs up if you think that is true, or maybe if it's wrong, just do a thumbs down. Give a reaction. Okay. Now let's go right into the U chart, which is again part of the attribute data. And in this, you can see that there are different processes that can have different outputs. So if you have it at the right back position, you know that you're going to stop the through balls coming in from the central midfield, right? But then there could be many other defects. Maybe your defender could be very unfit, he could be very slow at that particular position. And so all these defects are then put into one single chart because there's many number of defects. Not just you're not focusing now on one, but now you're focusing on many different defects of a sample per hour. And this is very good used in pre-production design if you're using the manufacturing. But if you're using a sport, you can find that you can have a defect in a person such as speed. You can find that he is not being trained enough on the through ball, so his vision is not correct. But there's very many ways of measuring that through quality testing. You can see that through your fitness instructors. They can give a pass or a fail towards a certain player's fitness. And then all that is then coming into one particular chart. And this is how the U chart will work using the three sigma above and three sigma below. So let's get into the next chart, which is an NP chart. So an NP chart is again similar to a U chart, but it's used when the sample size is constant through the process. Now, a U chart is used where the sample size is not constant. You can have maybe 3 samples in an hour or 2 samples in an hour, but an NP chart is used where there is only 5 samples or 6 samples within a particular hour. Now, if you can notice that in this particular chart, it's quite interesting because you can see that at this particular point, it's going above this upper control limit. So this particular process might not be that much in control as it is required, because if it was in control, it would be right around this center line right over here. And at this particular moment, it's not really in control. And hence why you can find that many different charts are used for many different kinds of data interpretation, and it's very important to use these particular charts. Okay, now I've talked to you about all these 4 different charts, and obviously all of these charts exist within the you know the selection of a control chart. But please let me know or give me a like or a comment if you would want to know about the remaining. And please subscribe to my channel for your support, because I really need your support in my channel. And I appreciate all that you're doing for me and all the views you're giving me. And you're one of my biggest supporters. So I really love it when you guys show some form of reaction, and make sure you put it down below in the comment section. Now, let me tell you about my conclusions and my final thoughts on this topic. So, statistical process charts are very useful in identifying successes and failures of a process by using different charts. Now, after this video, I hope you guys can see why Manchester United failed over the weekend against Everton, because they had a lot of problems in their processes, and I was so disappointed by it. I just can't begin to, just say it all out. Now, this process can help the quality teams to start corrective actions and catch the errors before they become worse. So, bringing in Cristiano Ronaldo after halftime, that's an error in the process, because how did he think that people are tired to play after the Champions League match? Although, these charts are great for catching the common causes rather than the special causes. So, the special causes, as we talked about last week, and I'll leave a link down below for my previous video, is that special causes are basically your out of the box. Like, let's say a player who's playing a match, Mo Salah today, of Liverpool, he just gets injured completely. That is a special cause, because somebody just tackled him. But if you keep on overtraining them and overworking them, that then can lead to an injury, and obviously then, then that is called a common cause.